All right, welcome. Today we're learning about when we have expressions that have a power or an exponent to a power. Okay, so something like this where we have a power on top of another power. So we're going to see the relationship between that. Before we learn the relationship is when we divide expressions that have exponents. Where when we divide, we subtract their exponents. We also learned when we multiply expressions with exponents, we add those exponents. Okay, so those are kind of things we learned in the past. If we had something like x to the a times x to the b, what we did is we added those exponents. If we had something like x to the a divided by x to the b, well, that's x to the a minus b, so we subtract. Now we're going to see what happens when we have something that's like x to the a to the b. Okay, so that's the goal for today. All right, so let's explore. So 6 to the third, well, we could write that as 6 times 6 times 6, okay, which ends up giving us 216. Okay, but now let's look at one where we have a power inside of a power. Okay. So here what we did is we multiplied what's inside twice, okay? So we could rewrite this as 6 squared times 6 squared times 6 squared. Well, that's just the same thing as 6 times 6, okay? And that ends up giving us 6 to the 6th. Okay, so we want to find a relationship between when we have a power inside of a power and its answer, okay? And here we'd want to simplify further. I think that gives us 46,656, okay? But let's look at another example. Okay, we're going to probably skip this one. Well, let's do it. That's x times x 4 times, right? So here we'd do the same sort of thing. We could do x to the third times x to the third times x to the third times x to the third, 4 times, okay? And then we can expand that even further. That'd be 3 x's for each okay, so we have 1, 2, 3, 4. That ends up giving us, it's the same as x to the 12th, right? So hopefully now you've kind of start to realize the relationship between the a and b, like the 3 and the 4, and how it relates to 12. How does 2 and 3 relate to 6? Okay, so probably there you realize that whenever we have a power inside of a power, we multiply those exponents. So they'll be the same as x to the a times b. All right, so here we can do it a little quicker now that we know the relationship. And I guess this is a power inside of a power. I guess let's go over these other ones, okay? So this is already simplified. We can't do anything with that one. This one we can simplify. That would be 2 times a times 2 times a. That gives us 4a squared. Okay? And here's a power inside of a power. Okay? So remember, what we're going to do is we're going to multiply their exponents. You could say that there's an exponent on the 2, if that helps. So you could do 2 to the 1 times 2, and you could do x to the 2 times 2. It ends up giving us 2 squared and x to the 4th. Well, that's just 4x to the 4th. Okay? Here's another example. Again, you're going to do the same thing. This is going to be 3 squared. This would be x 2 times 2, and we do y 3 times 2. So we just multiply their exponents when we have a power inside of a power. So that gives us 9x to the 4th, y to the 6th. Okay? So here we can write down this. Describe the pattern you see if you raise a power to a power, okay, you multiply the exponents. Okay? All right? And that relationship, we'll just rewrite here. So the example here would be something like x to the a, which could be any number, to the b. Well, that is just going to be x to the a times b. Some other examples could be something like x to the 5th to the 6th. Okay, that's just x to the 30. So like when we started by just expanding and doing it that way, but when you start getting bigger numbers, you don't want to draw 30 x's. Okay? Here's another one. Doesn't matter if it's on the top or the bottom. So if we have one in the denominator, okay, that would end up giving us 1 over 2 to the 3rd. Well, that's 8. And x to the 4th to the 3rd. So x times 3. That gives us x to the 12th. Okay? All right. But this one is the one that works for any type of problem, whatever a or b is. Those are just your numbers. Okay, so let's do some expressions. We can expand them, we can simplify. A lot of these, just knowing the rule is probably the easiest way rather than expanding. So here, I mean, you could do 2 to the 3rd. Well, that's just 2 times 2 times 2 squared, and then expand it further. 2 times 2 times 2 times 2 times 2 times 2. That ends up giving us 2 to the 6th. Okay, so you could do it that way. That gives you 64. Or you could just realize the rule where that would be 2 to the 3 plus 2, which gives us, or not plus, multiply. It gives us 2 to the 6. So that's much easier, and you end up getting the same answer. Okay? Here's another one with variables. So the easiest way would just be x to the 4th times 3 gives you x to the 12th. Okay, so that would be our x to the 12th. If we were to expand it, yeah, we would end up having x times x times x to the 3rd, and then we need to expand that even further. X times x times x times x 3 times. Okay, and you'd still end up getting 12 x's, so that would be x to the 12th. Okay, all right, again, you could say that could be a 1, and then we are going to do that again. So a to the 1 times 4, and b to the 2 times 4. That ends up giving us a to the 4th and b to the 8th. Or you could expand it again, but I think the easiest way is just to do it that way. All right, some more. Again, you could say that as a 1, so that would be 3 to the 1 times 2, and c to the 5 times 2. That gives us 3 squared times c to the 10th. Okay, and then we can simplify 3 squared, that's just 9 c to the 10th. Okay. All right. You do it again. This would be 2 to the 1 times -4, and x to the 6 times a -4. Okay, so that's one way you could do that. Multiply that together. That would give us 2 to the -4 and x to the -24. And then we'd need to bring it down so we don't have negative exponents. Or you could do it at the beginning. You could bring this down and say 1 over 2x to the 6th to the +4th, and do the same sort of thing. So that would be 1 over 2 to the 4th, x to the 24th. And we end up getting 1 over 16x to the 24th. Okay, and then you'd end up getting the same thing. Okay. All right. I guess we should write that over here. So 1 over 16x to the 24th. Okay, here's another one. Again, like, I'm okay if you think about it as distributing the exponent, as long as you realize that you can't do it when you have addition or subtraction in there, okay? So that would be 3 squared, x to the 5 times 2, y to the 3 times 2. On the denominator, we'd have x to the 3 times 3 and y to the 1 times 3. Okay, so that would end up giving us 9x to the 10th, y to the 6th, over x to the 9th, y to the 3rd. And then we just need to, since we're dividing things, we would subtract their exponents. So it'd be 9x to the 10 minus 9, okay? Y to the 6 minus 3 would end up getting 9x to the 1 times y to the 3. Okay? All right, so I do it again. Again, since we're squaring this, everything is going to be squared. All right, so we distribute it to everything. Or we could evaluate what's inside. Maybe we should do that first. So again, like you said, it doesn't really matter what order you do it. You'll end up getting the same thing as long as you use the same rules. Okay, so let's simplify what's inside the parenthesis first. All right, so we have a negative exponent. We'd probably want to bring that down. So that would give us 2y to the 3rd over 4x to the 3rd, x to the 5th, and would have y. And then here these are being subtracted, their exponents are being subtracted, so 2 to the y to the 3 minus 1. And on the bottom we'd have 4x to the 3rd plus 5, since these are being multiplied. So we'd end up getting 2/4 is the same as 1/2. Y squared over x to the 8th. Okay. And then we can distribute these squares. Okay, so it would be y to the 2 times 2 all over 2 to the 2 x to the 8 times 2. And that ends up giving us y to the 4th over 4x to the 16th. Okay, here's another problem. Okay, here we have the 0 property. So anything to the 0 is 1. So we could quickly write it like this. Okay, and then we have a power inside of a power, so we can distribute that exponent. So that gives us 1 over 4 squared and x to the 4 times 2. Ends up giving us 1 over 16 x to the 8th. Okay, write this over here, 1 over 16 x to the 8th. Okay, 9. Okay, I feel like this is a lot of problems, but we probably won't do all of this in class. All right, should we try doing this using, well, let's do it the same way, okay? So here again we have the 0 property here. Exponent is 0, so this whole thing on the denominator is 1. And anything divided by 1, I guess we could write it like this, x squared, 7 to the 3rd squared over 1. But anything divided by 1 is, you don't need to write that again, okay? All right, and then we distribute those exponents. We're multiplying everything, all the exponents. So that'd be 7 squared, x to the squared times 2, and y to the 3rd times 2. Okay, and then would end up getting our answer. Would be something like 7 squared, well that's 49, x to the 4th, y to the 6th. Okay, and then the last one, we have a 0 exponent again, and it applies to everything in that parenthesis, so the whole thing is just 1. Okay. And the last two problems, express the area of each square below as a monomial. Okay, so monomial is a single term. Okay, so basically the area of a square is something like a times s squared, where these are all the same sides, something like that. Okay, so we want to write it as a single term. So to find the area of a square, what we're going to do is we'll just multiply 9c squared, or to the 6th, sorry, and we square it. Okay, and that's the same thing as 9c to the 6th d times 9c to the 6th d. Okay, so we could do this either way. Here, everything at the top we could just distribute. We could say that would be 9 squared c to the 6 times 2 and d squared. Or if you wanted to expand like we did here, you'd end up getting 9 times 9. Well, that's 9 squared. Would have c to the 6th times c to the 6th. Well, that's just c to the 12th. And then would have d times d, that's d squared. Okay, so either way, you end up getting the same thing. So here our area would be 81. 9 squared is 81. C to the 12th, d squared. Okay, probably could have done that a little more simple. Let's look at this one. Okay, so we want to find the area. It's going to be 14 g to the 5th, h to the 9th, and we're just going to square it, okay, because all the sides are the same. So then we can expand. That would be 14 squared, and g to the 5th times 2, and h to the 9 times 2. Okay, it gives us 196 g to the 10, and h to the 18. All right, so if you have any questions, let me know. We'll be doing our review shortly after, and you'll do great. Okay, see you.